So one last bit of information about Mars's atmosphere. So the way it is today, as we said, it's 95% CO2 and about 1/100th of Earth's pressure. So 95% carbon dioxide, about 100th of the pressure on the Earth. So of course the takeaway from all this is that Mars has a very thin atmosphere. And as we saw in the last few videos, it keeps the planet very cold because there's no carbon dioxide to trap the heat, and it makes it hard to land. So Mars is just sort of this tough planet. So this is, well, how did it get this way? And there is some idea out there that perhaps a long time ago Mars was not like this. It's possible that Mars was sitting here like this, and I'll draw some CO2 here in orange, I guess. It had a nice thick carbon dioxide atmosphere, and there is evidence that water used to flow and that sort of thing. So maybe Mars was a nice, lush, and maybe habitable planet one time, a long time ago. So how did it get to this state here of still hanging on to 95% CO2, very thin though in its atmosphere? How would that have happened? Well, you'll never guess, but once again, you know, the sun is sitting here, and once again, it's that darn solar wind, right? So the solar wind are mostly protons and electrons, so protons and electrons just streaming across the solar system. And in the absence of a good magnetic field, of course, Mars is getting hit by the solar wind. And so once again, one of these processes that takes off here is that when maybe some of the solar wind in this action right here, so the question is, well, if you have some solar wind plus CO2, what happens? Well, it causes the CO2 sort of to leave. Causes the CO2 to leave the atmosphere. And there's actually a figure on it that's something like to leave to the tune of something like 1/4 of a pound per second. That's what the solar wind causes to happen. So it's one of these things, again, the sun and its darn solar wind, all these problems that it causes, the things that we discussed, you know, well, the auroras, which aren't a problem, but they're beautiful, but that may have been what started to etch away at Mars's otherwise thick carbon dioxide atmosphere that maybe it had one day, because maybe Mars was warm enough to even allow water to flow. Not so anymore. So another consequence of that solar wind coming into something that might have happened on Mars. And then what might have happened after that, of course, as the atmosphere got thin, Mars would start to cool because that IR is going to start escaping. Right? The infrared is going to start escaping. And so what might have happened then is you have Mars like this here. Here's Mars, and here's the carbon dioxide, which is getting really thin. And so what would happen then on the surface of Mars, it would start to get kind of cold here. And what that's going to do at that point is going to freeze the carbon dioxide out of the atmosphere. So sort of like a greenhouse effect in reverse. Remember, the more carbon dioxide you put in an atmosphere, the warmer the planet tends to get. But as you start to lose carbon dioxide, maybe by the solar wind here, as this loss process starts, you start to lose carbon dioxide, the planet's going to start to cool to the point where it's even going to start freezing carbon dioxide out of the atmosphere. So instead of like a little bit of molecule of carbon dioxide floating around in the atmosphere doing its thing to trap IR, it's going to start freezing. It's going to just start falling out of the sky and maybe freezing, kind of like snow, because it's just starting to get too cold. But of course, this exacerbates the effect, right? As all these CO2 molecules start to leave the atmosphere and freeze, no more IR trapping anymore. The IR is just going to escape, and the planet's going to further cool down. So the solar wind would keep making the atmosphere cool thinner anyway. Now the carbon dioxide is freezing out of the atmosphere, making it still thinner, and that's kind of how Mars got to the way it is today. So it's not clear how the solar wind started to etch away at the atmosphere. Maybe it was always like that, or maybe there was some sudden shift in Mars's planet that caused its magnetic field to shut off and the solar wind to start to penetrate deep in the atmosphere. These are some of the things we just don't know, but Google searches might lead you on the way. But it's just kind of interesting then that the Mars situation is sort of like a greenhouse effect in reverse. Believe it or not. Gaining carbon dioxide heats your atmosphere and your planet, but losing it's going to cause it to cool off. So anyway, that's it for us for Mars, and hope you enjoyed all that.